Sahana, good evening. Voice very low. So just a minute. Now it's audible? Okay. Yeah, thank you, Noor. Very good evening, Sahana. Good evening. Okay. So today we are going to talk about one interesting topic, that is vehicle dynamic simulation model with terrain effects. So this topic is extremely interesting topic, because when you apply the brake and what will happen in that electric vehicle, what will happen in that vehicle dynamic simulation model. So today we are going to discuss this one. So vehicle dynamic simulation model with terrain effect. So already we have learned how to build the basic vehicle simulation model in MATLAB Simulink. So we are going to discuss in deeply with braking system. And also additionally we are giving the terrain input using a lookup table. So I will tell you what is this lookup table. So in our last session, so this is the final project of our EV design 21 days masterclass series. This is EV half car trial model. So finally you are going to make this MATLAB Simulink model, EV half car trial model. So first you have to create the vehicle body subsystem. So this is the step 1. So already we have done this model in our MATLAB Simulink. So today we are going to additionally add terrain effects. So my voice is low. So just a minute. Now it's audible. Okay. So in our last session, we have developed this model. So today we are going to adding 2 more sensors in this simulation. I will use why add this sensors in our simulation model. So the first block name is ideal force sensor, and next one is the ideal torque sensor. Okay, I will show you that model. So this is the simulation model. And here we are applying the 2 brakes for our rear axle, rear tire, and also the front tire. So I am going to open the subsystem. Here you can see the 2 sensors will be adding for the simulation model. One is force sensor, another one is torque sensor. So first one, I will tell you what is the ideal force sensor. So what is the purpose we are using here? First of all, basically this ideal force sensor is one kind of the device that is used to measure the force passed through it. So it converts this measurement into the control signal. So basically this type of sensors is to be considered as an ideal one, because it does not depends on the factors like inertia and also the friction and also the delays or energy consumption like that. So it simply measures the force acting on the vehicle and then convert them into the signals into our simulation model can use. So that is why we are using that ideal force sensors on this rear tire. So here we have a 3 ports. So what are the ports? One is R port, another one is F port, another one is C port. So R port is nothing but mechanical translational conserving port. So listen carefully, R and C port is the conserving port. That means mechanical translational conserving port. So this port is connected to the mechanical component where the force is being measured. So it represents one side of the sensor through which the force enters or exits. So in our simulation, the port is connected to the hub of the vehicle. So next one is the C port. What is this C port? This is also considered as a conserving port, mechanical translational conserving port. So this port is the other side of the sensor where the force continues after passing through that sensor. So this C port, it allows the force to be transmitted through the sensors without any losses or delays. So this is what the C port. So next one is the EF port. So this F port is the output port. So that means physical signal output port. So this port is it going to measure the force as a physical signal. So these physical signals can be used in other parts of your simulation model for a monitoring and also control or further calculations. So it converts a mechanical force into a usable electrical signal for analysis and also the control purpose. So why we connect this ideal force sensors to the hub of our vehicle? So this question comes in your mind. Why we connect this ideal force sensor connect to this hub of our electric vehicle, hub of our vehicle body? So what is the purpose? Why we connect that one? So we have to connect the sensors to the hub of the vehicle because the hub is a critical point where various forces come together. So by measuring the forces at the hub in the sense, we can get a clear picture view. We can get a clear picture of the forces that acting on the vehicle, including those from braking conditions and also the road conditions. So this accurate measurement is a very crucial for analyzing the vehicle dynamic and also the vehicle's performance and controlling systems. It's like a braking or a traction like that. So it helps us to understand our simulation model to ensure it our real world behavior. So next we will see the ideal torque sensor. So what is this ideal torque sensor? So basically the ideal torque sensor is also one kind of the device that measures the torque in a mechanical system and converts into the electrical signal. So it is also called as the ideal because it does not depend on the factors like inertia, frictions and also the delays. So what are the ports of the ideal sensor here? We have a 3 ports, port R and port C and also the port T. So first one is the conserving port. So conserving port here, port R and port C. So the port R that is connected to one side of the mechanical system where the torque is applied. So port C is connected to the other side of the mechanical system where the torque is to be being monitored. So port T, that is a physical signal port. So this port is the output port that measured torque as a physical signal that can be used in other parts of our simulation. So why we connect the torque sensors to the front tire? So in our simulation, we connect the C port of the ideal torque sensor to the A port of the front tire. So what is the meaning of this A of this front tire? So what is the meaning of the A port of this front tire? So already we discussed these things. I am asking a question to you. What is the meaning of this A of the front tire? What does it mean? What is that port? A port. What is that A port? Anyone? What is the A port of this front tire? What is the meaning of that A port? What is the purpose of that A port? Do you have any idea? Because already this thing we have discussed in our previous classes. Okay, I will tell you. So A port is nothing but axle. So this is one kind of the rotational motion. So this is where the rotational motion from the vehicle's axis that is applied to the motor. So no, not accelerator. So that is the axle. So this axle port, A port, it simulates how the tires receiving, driving or a braking torque. So H is the hub port. So we already know H is the hub port and N port is a normal force port. So this port is an input, the vertical load or a normal force acting on the tire. So S is nothing but slip port. So this is the also output port. So which tell us how much the tire is slipping relative to the forward motion. So that is what the slip port. So why our torque sensor is connected to the A port of the tire? So first you have to understanding the tire dynamics. So by measuring the torque at the axle in the sense, we can analyze how the torque, how the tire, it responds to the different driving conditions such as acceleration and deceleration and also the some cornering. So that is why we have to connect our ideal torque sensor to a port of the front tire. Okay. So this is the two sensors we have to add here, and now I am going to, so S port is nothing but a slip port, Lakshmi. S port is nothing but slip port. So this is one kind of the output port. So it tells how much the tire is slipping. So next we have to make the subsystem. Okay. So next we have to make the subsystem. So if you want to make the subsystem, so select all the components, select all the blocks and press the Ctrl G. So this is the way you are going to create a subsystem. Select all the components, select all the blocks and press the Ctrl G. This is our subsystem. So this is our subsystem. So next we have to give the some slope and distance value through this lookup table. So we have to give the values, slope versus distance values here through this lookup table. So first of all, so just a minute. Okay. So I am going to load that terrain data. So first of all, I am going to load that terrain data in our simulation model. So just a minute. Yeah. So this is our terrain data. So we are providing the slope and distance values to terrain in a simulation to see how our model analyze how different types of terrain affect our vehicle. So this helps you understand how the vehicle behaves under various conditions, including uphill or downhill slopes, and you can assess its speed and you can assess the acceleration and how energy usage on a different tires. So that is why we have to use this terrain data. So now I am going to plot the simulation here, plot the data here. So the X position, this is our X position, comma, Y position. I will show you what is the data that. So slope versus distance. So once you click this, yeah. So this is our slope versus distance value. So now I am going to give this value into a lookup table. So this is our lookup table. So you have a lookup table in your Simulink model in the sense that stores the terrain profile information. So that means this lookup table, it consists of the two inputs. One is a slope, another one is a distance. So slope values may represent the incline or a grade of the terrain at different distances along its vehicle path. So this lookup table, it contains the predefined data points or some mathematical model that defines how the slope of the terrain changes with the distance. So we have to connect this lookup table in our simulation model that accepts the terrain data. So this connection, it allows the vehicle model to access that terrain information during the simulation. So that is why we have to use this PS lookup table here. So what is the purpose of creating this lookup table in the sense? We have to define the characteristics of the terrain the vehicle will encounter in the simulation. So it helps you simulate the real world terrain conditions, and you can analyze how the vehicle behaves on a different slopes and at a different positions along its path. So this one it is a very crucial for studying the vehicle performance and also some control systems testing and understanding how the terrain affects and energy efficiency also. So now I will show you the slope versus distance figure. So this is our slope versus distance. So initially our vehicle in a zero condition. So after we introduce the negative value. So whenever our vehicle reach the 10 seconds in the sense, this one after the vehicle will reach the zero position. So that is no slope after the 10 seconds. So let us check what is the response our vehicle travel during this condition. So that is why we have to create this slope versus distance value. So now I am going to tell you that one. So before I am going to run this one, just a minute. Okay. So now I am going to run this simulation. Let's see carefully. So let's see what is the response or vehicle dynamic model travel during this condition. So this is our slope versus distance value. So do you have any doubt in this? Do you have any doubt? Yeah. So let's see our speed and distance waveform here. So double click on this scope. You can see your speed and also the distance. So this one is the speed profile and this one is the distance profile. So till 10 seconds, here you can see the till 10 seconds, the slope has been applied. So after that, the slope has been 0. So it is decreasing. So the vehicle speed is keep on increasing. After the 10 seconds, the vehicle speed is the vehicle speed is reduced. So once the vehicle reaches the flat surface, the speed of the vehicle also comes down. So once vehicle speed to 0 in the sense, the distance covered also limited. So this slope versus distance terrain profile, that means incline angle. So if your vehicle response is like this in the sense, then your free body diagram is perfectly ready to connect your remaining electric parts of your electric vehicle. So this one is a vehicle behave without braking mechanism. So now let us introduce a braking mechanism. I will show you. So let's see our distance value is 30.73. So now I am going to introduce braking mechanism here. So this is our braking mechanism. Now I am going to connect this one into rear brake and also the front brake. One is rear brake, another one is the front brake. So do you have any doubt in this? Do you have any doubt? Do you have any doubt means please mention in the chat box. Is it buffering? Do you have any other doubts? So before I'm going to enter the braking mechanism, I will tell you the internship information. So just a minute. Okay. So this is the live class versus internship benefits. So in our live class, you will get free sessions and you will get the demo and you will get an idea about a topic related to electric vehicle. And you will get 21 days only. So this is the live class benefits. And if you are an internship user, you will get recorded sessions and you will get complete simulation models. How to build the model and how to create the subsystem and how to simulate these simulations, especially vehicle dynamic simulation and also the DC motor simulation like that. And you will get mentor support and also you will have a weekly doubt clarification session. And also you will get 9 days, additional 9 days of recorded content if you are an internship user. Yeah, Rohit Kumar, definitely I will teach how to create these subsystems and how to create vehicle dynamic simulation model in our doubt clarification session. So you can convert the masterclass into 1 month internship. So the actual price is 1,999. We are offering the discounted fees. That's a 799 plus 18% GST. So use this registration link to join as an internship user because this offer will be closed on 7/6/2024. And also if you are an internship user in the sense 8/6/2024, you will have a hackathon session. That means doubt clarification session. And so this is the project 4 and the project 4 is 3S2P. That means 3 cells in series and 2 cells in parallel. So this is a battery pack model simulation and this one is the project 4 and the project 3 is cell balancing. So what are the cell balancing methods available in electric vehicle? And this one is active cell balancing. So how to build this active cell balancing in a MATLAB Simulink. So this one is the project 4. Sorry, project 3. And next one is the project 2. And the project 2, you will get the battery pack model. So first you have to create the parallel assembly from the cell. And after that you have to create a battery model and then move on to the battery model assembly and finally you are going to create the battery pack. So this is the battery pack simulation outputs. And if you are an internship user, this is your agenda for your 30 days of electric vehicle design internship. So what are the forces acting on electric vehicle and what are power calculations of electric vehicle and also the power converter design, power inverter design and DC speed motor controller. So in our live session, we will only cover the DC motor, but if you are an internship user, you will get BLDC motor and AC induction motor and also the PMSM motor and SRM motor control. And you will have powertrain modeling simulation and microcontroller for EV application and sensor circuit design for EV application and Arduino based induction motor control. And finally, you will have EV model fabrication design simulation also. So these are all the agenda for internship user. And one more thing, we are offering exclusive 3-in-1 EV design bundle. So this EV design bundle, you will get 3 big masterclass. One is EV design masterclass and also PCB design and also you will get MATLAB Simulink. So EV design, that is for 30 hours, that means 30 days and MATLAB Simulink also 30 days. In MATLAB Simulink, so you will get all the power electronics related simulations. And PCB design, you will get 10 to 12 hours. So that means single layer PCB and also the double layer PCB. So this is your EV design bundle. So this offer also will be closed on 7/6/2024. So don't miss out this opportunity. And benefits of this EV design bundle, you will get 90 days of live sessions and 1 year validity of records and 20 plus simulation files and also the source codes, and you will get community groups and I will give you the assignments based on this EV design and also the MATLAB Simulink, and you will get 90 downloadable presentation and you will get internship confirmation letter and internship certification. So don't miss out this opportunity. So now I am going to tell you, we are going to apply a break in this simulation model. So I will show you, this is the slope, right? So this one is the, just a minute. Yeah. So this is our slope versus distance values. Initially our vehicle in a 0 position. So after we applying the negative values, And here, whenever our download slope is applied to our model in the sense, up to 10 seconds, we are applying 2 brakes in this simulation. So we are applying 2 brakes. So here one brake and here second brake. So for applying a brake, we use a loaded contact frictional block. So listen carefully. When you are applying a brake, we have to use this block. So what is the block name? So loaded contact frictional block. So this is the block name. And here we are having a 3 ports. One is a N port, another one is a B port, another one is a F port. So N port is nothing but this port is represents the force pressing the 2 surfaces together. So when this force exceeds a certain threshold limit, in the sense, the friction occurs between the surfaces. And next one is the B, that means a base, and F means follower. So these are the mechanical rotational conserving port. So they facilitate the transfer of torque between the connected components. So B is a stationary part, and while F is the rotating part. So now we are going to connecting a step waveform into a brake. So this step waveform, it represents the activation of the brakes. So connecting to the brake input port, it implies you are controlling the brake application over the time using the step input. So during a downhill drive, as a vehicle deceleration from the downhill, so the brake applied to control the speed and also maintain the driving conditions. So this step waveform, this one is a step waveform, it initiates the brake application in the beginning of the downhill drive and maintains for a specific duration. So in this case, 10 seconds. So applying the brake during a downhill drive, in the sense, it helps to regulate the vehicle's speed and also it prevents it from accelerating uncontrollably. So by connecting the step waveform to the brake input port, we are simulating the activation. We are simulating the dynamic activation of the brakes during the specified time frame. So now I am going to run the simulation here. Let's see. So just note the distance value before we applying the brake. So now I am going to show the distance value. So we are applying 2 brakes during this downhill drive using the step waveform, in the sense. You have to analyze, you have to study the effects of braking on the vehicle's speed and also the stability, overall performance in such scenarios. So it helps us to know how effectively the brakes control the vehicle's downward motion. And also you can maintain the safe drive conditions also. Yeah. So let's see the scope here. So distance is reduced. So when you apply the 2 brakes for up to 10 seconds during a downhill drive, in the sense, the distance covered by the vehicle is reduced because the brakes slow down the vehicle's speed. Right? So the brakes are applied, in the sense, the vehicle decelerates. So that means it covers a less distance over the time compared to when it's moving at a constant speed. So let's see the output. Yeah. So this is the output here. So this one is the speed waveform and this one is the distance waveform. So what is step input value here? So the first rear brake input value is 20. So step time is 20 and this one is 25. So at 20 and 25, we are applying a brake. So here listen carefully. So the step 20 and also the step 25, we are applying a brake. So the distance will be covered less due to that previous condition. So do you have any doubt? Do you have any doubt in this why we are going to applying a brake? So this is just a scenario. So when you are driving a downhill, in the sense, we are applying 2 brakes. So at that time, what will happen in our vehicle body? Vehicle dynamic simulation model. Yeah, that is a disadvantage for EV Vale Murugan. So this is for just for the scenario. For a different terrain inputs, how vehicle will respond. So Kuruksha, this one is the MATLAB simulation, MATLAB 2022B version. So any other doubt? Any other doubt? So Hamad, here the distance will be reduced. So when you apply 2 brakes up to the 10 seconds in the sense during a downhill drive, so the distance covered by the vehicle is reduced because the brake slows down the vehicle speed, right? So when you are applying a brake, the vehicle decelerates. That means it covers a less distance over the time compared to when it's moving on a constant speed. So Sudhir, you can use the online trial version, free online trial version for a 1 month. If you are an internship user, I will you share this simulation file. Balakrishna. Okay. So this is all about today's session. Any other doubts? This is our output and this is our vehicle dynamic simulation model. So this one is the project 1. I will you show that image. So this one. This is your final EV project. EV half-car trial. And first subsystem is vehicle body and next one is the motor controller part and next one is the longitudinal driver block and next one is the battery block. So first we have to create a vehicle body subsystem. So we successfully create that vehicle body subsystem. After we are going to motor controller part and next one is the battery block. So in our battery block, you have to calculate your SOC of your battery. Because battery block in the sense, inside the battery block, we have a number of cells connected in a series or a parallel manner. So we have to monitor all the cells. So that is why we have to calculate SOC and SOH from that battery block. And how to create that battery pack in a MATLAB simulation also. This is one of the project from your internship. Okay. So now I will tell you the again information about internship. So you can convert this masterclass into 1 month internship. The actual price is 1,999 and we are giving discounted fees 799 plus 18% GST. So use this registration link to join as an internship user. So Karthik, you have to use online free version, online MATLAB free trial version for a 1 month. We are not providing that MATLAB version. Any other doubt? If you are an internship user, you will get nearly 5 to 6 projects. So the first project is vehicle dynamic simulation project and the next project is battery pack and the project 4 is this one. So the 3S2P, that means 3 cells in series and 2 cells in parallel battery pack. How to create the battery pack in MATLAB simulation. And then cell balancing. What is cell balancing? Why do we need cell balancing? And what are the cell balancing types available? These are the things you can get from the battery management system topic. And this one is active cell balancing. And next project 2 is battery pack creation. How to create a battery pack in a MATLAB Simulink. Karthik, if you are an internship user, you will get the MATLAB simulation files and also the PPT. Any other doubts related to the internship or related to our content? Any other doubt? Lakshmi, do you need electric vehicle offline mode? Okay. Any other doubt, guys? So this is all about today's session. And again, I will tell you, if you are internship user, you will get additional 9 days of recorded content. And also, we are offering exclusive 3-in-1 internship EV design bundle. You will get 3 big master classes: EV design, PCB design, and also the MATLAB Simulink. And this offer will be closed on 7/6/2024. And you will have doubt clarification session on 8/6/2024. That means coming Saturday. If you are an internship user, you will have doubt clarification session. Lakshmi and I am here. The coordinator will contact you about your offline mode. Any other doubts? So don't miss out this exciting opportunity to join as an internship user. You will get exciting benefits. Okay. So thank you so much. Thanks to everyone who joined today's session. Yeah, Balakrishna, I will give you the assignment based on electric vehicle design. I will you give 3 assignment, and you have to finish this assignment, and you have to post that assignment results in our community page, LinkedIn page. So Amar, what is your query? Is there any problem with the attendance sheet? Yeah, thank you, Bharat sir. Thank you for your words. Thank you for your valuable feedback. So how was the session? How was the session? Please mention in the chat box. How was the session? Yeah, thank you, sir. Thank you, Bharat sir. Thank you, Gomati, and thank you, Ravinder. Thank you. So if you are really like the session, please please give thumbs up in the live chat. Thank you, Akshit. Thank you, Gururaj, and thank you, Satyavani. Thank you so much. Thank you, Shrishma. Thank you, Priyanka. Ahmad, thank you. Thank you all. Thanks to everyone. Yeah. Thank you, Sri Krishna. Rabindra, thank you. Balakrishna, thank you. Thank you so much. Thanks to everyone who joined today's session. Thank you. Thank you so much. Tomorrow we will yeah, thank you. Thank you, Rohit Kumar. Thank you. Thank you so much. Thank you, Sony. Thank you, Velmurugan. Shiva, thank you. So definitely, Balakrishna, I will guide you. Thank you, Prince. Thank you all. Thank you so much. Thank you for your feedback also. Thank you.